Sairam, this is Megha Miss here, and today we will continue with our lesson number 10, Space Mission. Okay students, this is our session 2. As I told you before, theoretical lesson, and mostly it's a self-study lesson. Students, you go through it properly, read the textbook properly. Okay, now space missions away from the earth. Now we will start with a new topic, that is space missions away from the earth. As we have seen above, artificial satellites are being used for making our life more and more enriched. Yes. However, in the previous standard, we have learnt about how the telescopes abroad, artificial satellites, are used to gather information about various objects in the universe. Okay, so we have telescopes and all which are used abroad, and with we can get the information, right? Gather the information about the various objects which are there in the universe. Similarly, some space missions are used to gain further knowledge about the universe. In this mission, spacecrafts are sent to the nearby objects in the solar system to observe them more closely. New information has been obtained from such missions. Okay, so one by they the spacecrafts and all, they are sent, and yes, the information, every time a new information whatever is collected. Okay, so the new information has been obtained from such missions, and it is helping us to understand the creation and evolution of our solar system. So whatever the new informations we get each time, it is helping us in the further study of the evolution, creation of our solar system. Okay students, so for such missions, the spacecrafts must escape the Earth's gravitational force to travel into the outer space. You have studied about escape velocity, right? To achieve this, the initial velocity of the moving object must be greater than the escape velocity of the Earth, as we have learned in the chapter on gravity. Okay, escape velocity on a planet can be obtained using the formula, V escape is equal to root 2 gm upon r. We have studied this, student, okay, where g is the gravitational constant. Standard value 6.67 into 10 raised to minus 11, okay, Newton meter square per kg square. Then mass m, capital M, okay students, capital M is the mass of the planet, that is 6 into 10 raised to 24 kg for Earth. Okay, r is the radius of the planet, 6.4 into 10 raised to 6 meter for the Earth. So we are calculating this escape velocity with respect to the Earth, right? So V escape, when you calculate, put the values and get what escape velocity you get, that is 11.18 kilometer per second. Okay, so thus if a spacecraft is to escape the Earth's gravitational force to travel to the outer space, it must have minimum velocity of 11.2 kilometer per second. So if the spacecraft is having this minimum velocity, then only it can escape the Earth. Okay, so I hope this part is clear to you, students. We'll proceed. Moon missions. Okay, now since the moon is the closest astronomical object to us, the first space missions to objects in the solar system were the mission to the moon. Okay, such missions have so far been executed by USA, Soviet Union, European countries, China, Japan and India. The spacecrafts in the Luna series sent by Soviet Union reached near the moon. Okay, Luna 2, launched in 1959, was first such craft. After that, till 1975, 15 spacecrafts made chemical analysis of the moon and also measured its gravity, density and radiations. Last 4 crafts even landed on the moon and brought the samples of the stones on the moon for analysis in the laboratories. So see how much inventions have been made in science. Okay, that whatever the crafts went, they brought from there the samples of the stones which are there on the moon, and then it analysis was done in the laboratories. All these missions were unmanned. Okay, so America also executed moon missions from 1962 to 1972. The speciality of these missions was that some of these were manned mission. Okay, In July 1969, Neil Armstrong became the first human to step on the moon. This you know, student, okay? In 2008, Indian Space Research Organization, that is ISRO, successfully launched Chandrayaan-1 and placed it into an orbit around the moon. It sent useful information to Earth for about a year. For about a year, that particular whatever the Chandrayaan was sent, okay, the satellite was sent, it was sending the informations to the Earth, okay. The most important discovery made during the mission was the presence of water on the moon's surface, okay. So this was the what you can say, the most important discovery, okay students. India was the first country to discover this. So India is the first country who has discovered that with the help of the satellites, that yes, there is a presence of water on the moon's surface, okay students. So now we will see the Mars mission. Next to the moon, the astronomical object nearest to the Earth is the Mars. Many nations have sent this spacecrafts to the Mars. Mars mission is difficult and almost half the missions were unsuccessful. However, ISRO's performance in this mission is remarkable and we all must be proud of it. The spacecraft Mangalyaan, made by ISRO using minimum expenses, was launched in November 2013 and was placed into orbit around the Mars in September 2014. It obtained very useful information about the surface of the Mars and the atmosphere around it. So we must be really proud of ISRO. Okay students. So mission to other planets. Now we have seen mission to the moon, mission to the Mars. Now we will see to the other planets. Many missions have been executed to study other planets also. In some of these missions, the spacecrafts orbited the planets, some landed on the planets and some just passed near the planet and observed them. Okay students. Additionally, spacecrafts have been sent to observe asteroids and comets, and they have successfully collected some dust and stones from the asteroids and brought them back on the Earth. We are getting very useful information from all these missions, students, clarifying our concepts about the origin and evolution of the solar system. So all the study can have been made easy. Why students? Because of these satellites, as they are bringing very important information from different planets. Okay, so India and space technology. Now we'll see what India has done in this space technology. Okay, India also has made remarkable progress in the science and technology of launch vehicles. Various types of launch vehicles have been developed to put satellites having weight up to 2500 kg into all types of orbits. PSLV and GSLV are the two important launchers. The scientific and technological feats achieved by India in this field have a significant contribution to the national and social development. Okay, so yes, India has also done a remarkable work. It is inventing new launchers, okay, which you need for the satellites. Okay, INSAT and GSAT satellite series is actively working in the field of telecommunication, television broadcasting and meteorological services. Availability of television, telephone and internet services all over the nation has been possible, students, only due to these satellites. Okay, EduSat satellite in this series is used specially in the field of education. IRS satellite series is working for monitoring and management of natural resources and disaster management. To exactly locate position of any place on the Earth's surface in terms of its precise latitude and longitude, the IRNSS satellite series has been established. So different types of the satellites you can see, there is a series of satellites which have been established, students, for this study. Okay, now Space debris and its management. Now what are these space debris, students? In addition to the artificial satellite, some other objects are also revolving around the earth. Okay, it includes non-functional satellites. Okay, some satellites may not function, but they are in the space only. Parts of the launchers detached during launching, right? Some of the parts, you know na, they are moved, the fuel and the tank and all, it is leaving the right, to what you can say, make it less heavy, right? So where they are going, students? So during the launching, and debris are generated during the collision of satellite with other satellites. They can dash each other, right? Or any other object in the space. And where are all these materials? Okay, according to one estimation made in 2016, there are about 2 crore pieces of length more than 1 centimeter, students, revolving around the earth. All this is nothing but debris in the space. Debris means waste materials. Okay, student, this debris can be harmful to the artificial satellites. It can collide with the satellites or spacecrafts and damage them. This debris is increasing day by day. Soon it will be difficult to launch new spacecrafts. Okay, students, it is therefore very essential to manage the debris. Some studies and experiments are being done with this in view. So yes, study is going on how to control this increase of the debris. Hope that soon we will have a solution for this problem. Okay, and the future satellites and spacecraft will not be in danger anymore. Okay, students, so I hope space debris and its management is also, till now we don't have a proper solution in our hand, but yes, in future hopefully we are going to have some solution through which we can control this space debris. Okay, students, so here we end. That was the end part of our lesson. One more thing, students, the information of the scientist part and all has been deleted. So whatever part I have not taught you, it is not there for your exam this year. Okay, so we have ended with the chapter space debris and management was the end part. Now we are starting with the sums, and these are the sums which are your textual sums. Okay, so we'll just go through the sums, how we are going to solve them. Okay, students, so solve the, as I told you, theoretical chapter you have to learn it by heart. Okay, the points at least you know how I have told you how to write the points. Okay, now solve the following problems. First one we will see, if a mass of a planet is 8 times the mass of the earth and its radius is twice the radius of the earth. So the mass of the planet is 8 times more than that of the earth and its radius is twice the radius of the earth. What will be the escape velocity for that planet? That we have to calculate, student. Okay, escape velocity. So you know, given the mass of the planet M is 8 times the mass of the earth. Okay, so what we have to do, we are multiplying 8. Okay, 8 into 6 into 10 raised to 24 kg. Okay, the radius of the planet R is twice the radius of the earth. So what we have done, again we have multiplied by, as it is twice, we have multiplied by 2. 2 into 6.4 into 10 raised to 6 kilometers. G value, you know, it's a constant value, 6.67 into 10 raised to minus 11. Now the escape velocity for that planet, we'll use the formula, students. Now only we have seen V escape is equal to root 2 G capital M, okay, upon R. Okay, all these calculations I want you to do in your notebook and see whether you get the answer. Okay, calculation part is on you. You will do for this lesson. Okay, so when I substitute the values, what answer I am going to get? Simple, you will multiply. Okay, always remember that first whatever this raised to terms are there now, that you keep aside. Okay, that you handle at the end. First you do the multiplications of the numbers. Okay, so what you are getting, students, when I multiply, I am getting root 6.67 into 10 raised to 13 into 8 into 6 upon 64 into 10 raised to 5 I am getting. Okay, meter per second. Okay, students, so when I solve it, what I am going to get, root 6.6, all this calculation part you will do. Okay, root 6.67 into 3 upon 4 into 10 raised to 8. When I do the multiplication and divide, Okay, this multiplication is done, that I have got 20.01 upon 4. Okay, this 10 raised to 8 became 10 raised to 4 because I am shifting the points. Okay, but if you keep 10 raised to whatever the part is there, if you keep aside and you do it at the last, no problem. Okay, so your answer, you're going to get 2.237 into 10 raised to 4, which I can write as 22.37. okay, kilometers per second. I have converted meter per second to kilometers per second, so it became 22.37 kilometer per second. Okay students, I hope it is clear. Okay, you will do the calculation part. Okay, now we will proceed. I hope the formula you have understood. Only you have to put the values, do the calculation on your part. And as I told you, 10 raised to terms, you keep it aside and then you solve at the end. Okay, now B part we will see. How much time a satellite in an orbit at a height 35780 kilometers above Earth's surface would take if the mass of the Earth would have been 4 times its original mass. Okay, so we have to calculate the time here. Okay students, so we will see here, already answer is given approximately 12 hours. So we will see. Okay, we will solve and see. So now given our Earth, you know, 6,400 kilometers, which I can write 6.4 into 10 raised to 6 meter. When I am converting this kilometer, it has into meter, it has become 6.4 into 10 raised to 6 meter. Okay, M for the Earth, 6 into 10 raised to 24 kg. Now it is told that 4 times the mass, right? So M dash I will make it. So 4M, so I have multiplied by 4. Okay, H height is given 35780 kilometers, which I have converted to meters. Okay, so 3.578 into 10 raised to 7 meter. So I have just shifted the point and it became 10 raised to 6. Okay, 35.78 into 10 raised to 6 meter. G value, standard value, you have it. T we have to calculate. Now the time that the satellite would take to complete one revolution around the Earth, this formula you are going to use, students. Okay, T is equal to 2 pi R plus H upon VC. Okay, you are going to use this formula. Okay students, now we will just proceed. Now VC is equal to, now you know VC, escape velocity, you can calculate by Gm dash. Now we will write. Okay, Gm dash upon R plus H. Now VC value I have substituted in that T formula. Okay, so what I have got, T is equal to 2 pi R plus H upon root Gm dash upon R plus H. Okay, now you can see here 2 pi upon root Gm dash. Okay, it will be in the root R plus H 3 by 2. Okay, so what we have to do, 3 by 2 it has come. Yes, why? Because what we have done, this is in root, right? That I have taken up, so it is in root. So root it will become 3 by 2 when it goes up. Okay, now 2 pi I have substituted the values, whatever all values I have substituted. When I do the calculation, students, what I am going to get, that the value what I am going to get when you do the calculations here. Okay, you are going to get it, the I hope 3 by 2 here we have done. What you get, 2 pi for 42.18 into 10 raised to 6 raised to 3 by 2 upon 6.67 into 24. See, 4 6 are 24, that they have multiplied and written, and 10 raised to minus, this is 10 raised to minus 11 and 24, so it became 13. Okay students, I hope this part is clear. Then what it has become, see here, 42.18 raised to cube, it has become the cube. Okay, how it has become the cube, students? See here, it is 6 and raised to 3 by 2, right? So it has become cube, and here it has become 10 raised to 18. Okay, down it has become now 14. How 14? Because this I have made it 2.4. 24 I have changed to 2.4. So I have written 10 raised to 14. Okay, here see here, this will become. Okay, now what you are going to get, 2 into 3.142 into, see here, pi value I have substituted 3.14. You can take, no need of that 2. And I have solved here the root of 42.18 cube multiplied by 10 raised to 4 upon 6.67 into 2.4. Okay, how it became this 14 10 raised to 14, and here if it goes up, students, it will become 10 raised to 14 whatever I have taken, students, and this is the 10 raised to 18, okay, that they have sorted out and they have written as 10 into 10 raised to 4. Okay, so here now what we are going to do is, students, if you remove it from the root, you can take you can keep this as it is also, student, no need to do what they have done. Okay, here you can solve on your own. Yes, now approximately what you are going to get, 4.303 into 10 raised to 4 seconds. Okay, so approximately you have to convert it into hours, so I have to divide it by 3600, so approximately 11.95 hours you are going to get, that is 12 hours, approximately 12 hours if I round it off. Okay, I hope you are clear with this. Okay, students, now next sum, if the height of the satellite completing, yes, if the height of the satellite completing one revolution around the earth in t seconds is h1 meters, then what would be the height of the satellite taking 2 root 2 t seconds for one revolution? Okay, students, now this sum I want you to solve on your own. Okay, try to solve this sum on your own. You are going to do it and see. Okay, we'll just discuss it. Okay, given part time t seconds, height is taking h1. Okay, now let us assume that the height of the satellite completing one revolution in 2 root 2 t seconds as h2. We have taken height as h2. So what is known to you? You know this, t is equal to 2 pi r upon vc. Okay, what it can vc, I can write it as gm upon r plus h1. Okay, and 2 pi, here r is what? R plus h1. We have to take the height also. Okay, now what it will become? T, therefore t is equal to 2 pi root r plus h1, okay, cube upon gm. To be calculated, height h2 in time 2 root 2 t seconds. So t value we are going to take 2 root 2 t is equal to 2 pi, okay, root of what you have taken, r plus h1 cube upon gm. Okay, r plus h1 cube it is, right, upon gm. So that we have to solve. Okay, students, so when you solve it, this is your equation 1, t, and this is now t we have done. This is for h2, so h2 it will become r plus h2 cube upon gm. Okay, so 1 and 2 equations you have got, students, that you are going to solve. And yes, from equations 1 and 2, when you divide both the equations, you are going to get the equation. You will divide and see, h2 is equal to r plus 2h1. Okay, you do it on your own and you are going to solve. Okay, students, so here I think you can do it. You are going to solve it and see how to do it. Okay, you will be able to do it. Okay, try to solve it. Okay, students, and see what the answer you are getting. Okay, so I hope whatever part we have done today you have understood. Try to solve. If you are not understanding, we will solve it again. Okay, try to solve this sums in your books. Okay, so we'll meet in the this is our the last presentation for this lesson. We have completed with the lesson, students, and we will now do the revision, okay, of the lessons, and whatever doubts you have, you will be asking me. Okay, so we'll stop it here, and please solve these sums on your own and try it. When you will do it on your own, you will understand them. Okay, students, so I'll stop it here. Thank you. Saira.